Okay, next. We talked about graphing sine, we talked about graphing cosine, we talked about graphing tangent. Now I want to talk to you about graphing their reciprocals. Now, to graph cotangent, it's actually the function looks the reverse of the tangent. So whereas if you had a tangent function starting with a positive a, your function would increase from left to right. Cotangent, if you start with a positive a, you're going to be decreasing from left to right. So this is, again, the period of the cotangent follows the tangent, so period pi. Domain all real numbers except multiples of pi. Range all real numbers. Vertical asymptotes at those undefined values. X-intercepts midway between consecutive vertical asymptotes. Odd function, because again it is origin symmetry, and 1/4 and 3/4 of the way through have plus or minus a for your y coordinate. This time, instead of setting the function between negative pi over 2 and pi over 2, we're setting it between 0 and pi. So here's how we graph again. We set the inside of the function bx minus c, set the inside of the function between 0 and pi. Solve for x. Those are your first two asymptotes that we're going to work with. And then from there, we'll find out the 1/4 of the way, the midpoint of the way, and the 3/4 of the way through. So, here's an example. First step is to find two consecutive asymptotes, which means I'm going to take the inside of the function, 2x, and I'm going to set it between 0 and pi. And I'm going to solve for x. Anything 0 divided by any by 2, let's just say that, is 0. So here are my asymptotes. 0 and pi over 2. Next, I want to talk about finding the midpoint in my 1/4 and my 3/4 of the way through. Easiest thing to do, just set up a number line, mark off your asymptotes, and then start talking about distances. From 0 to pi over 2. The easiest thing to do if you're uncomfortable with distances is do this. You understand that distance would be a subtraction. For example, if I was on a 3 and I wanted to get to, let's say, 7, it would take me 4 steps. 7 minus 3. It would take me 4 steps. Now let's treat this the exact same way, okay? Anytime you want to come up with a distance, if it's on the positive side of 0, you do subtraction. Always work with the absolute value of numbers, because if you're working with negatives, you have to take into consideration that distance is always positive. So let's look at this example. Let's say I wanted to figure out the distance between 0 and pi over 2. Now, easiest thing to do, take away the pi and just put a 1 there. So the distance between 0 and a half. Now, if you don't know that that's a half, simply figure that out by doing some subtraction. 1/2 minus 0 will get you a half. So that means that the distance between here and here is pi over 2, because you have to put the pi back. Halfway between, what's the midpoint between pi over 2? Well, take a half and divide it by a half, and you'll get a 1/4. Oh, that must mean put the pi back. That must be it's pi over 4. What if I want the quarter length? Well, what's half of pi over 4? Divide by 2 again. You'll get an 1/8. Put the pi back. That means it's pi over 8. So let me go back. Let me pull back out our last problem we had. Because the last problem we did had, in the last section, it had negatives. So I want to talk to you about these, okay? First of all, how do I get the distance between negative 3 pi over 4 and 0? Well, talk about subtraction, right? You can talk about subtraction. Okay, 0, that's the further point away, right? 0 minus negative, take the pi away, 3 over 4. What's that going to get you? Oh, that's 3 over 4. So that means that this little distance is 3 over 4. Well, how do I get the distance between 0 and pi over 4? Pi over 4 is the further one away. Take the pi away, 1 over 4, subtract 0, will get you pi over 4. Oh, that means that this distance is, is 1/4. Okay, that means I have this distance, 3/4, plus this distance, 1/4. Well, what is 3/4 plus 1/4? Well, that's going to give you one whole value, right? 1. Put the pi back. 1 times pi is pi. That means from here through to here is distance pi. Let's say I want half this distance. Well, take your 1, divide by 2, give you a half, put the pi back, pi over 2. Say that you want half that. Well, take your half, divide it by 2. You get 1/4, put the pi back, pi over 4. And this is how you can do this for any of your problems. So let's go back to our problem. Okay, I forgot to do that in the last video. I wanted to definitely do it in this one, okay? So this is how we find our quarter length. Alright, so start with your asymptote of 0. Add your quarter length. So 0 plus pi over 8 gets you pi over 8. Take the 1 before it, plus that quarter length. So you get pi over 8 plus pi over 8. 2 pi over 8. 2 pi over 8 will give you pi over 4. Next, take that 1 before it, plus that quarter length. Take that pi over, oopsie. Take that pi over 4. Plus that quarter length, pi over 8. Pi over 8 plus 2 pi over 8 will get you 3 pi over 8. Okay, so that means that this is my 1/4, this is my mid, and this is my 3/4. Okay, great. Now I just have to evaluate the function, come up with my picture to graph it. Okay. So I have my x, I have my y equals 3 cotangent of 2x, I have my ordered pairs. The x's that I'll be looking at are my 1/4 of the way through, pi over 8, my midway through, pi over 4, and my 3/4 of the way through, 3 pi over 8. Okay, let's evaluate our function. 3 cotangent 2 times pi over 8, 3 cotangent pi over 4, 3, very good. Remember, for cotangent, cotangent's x over y. Using your unit circle, at pi over 4, x divided by y is 1. Always use your unit circle. Ordered pair, pi over 8 and 3. Next, 3 cotangent 2 times 0, 3 cotangent 0, which will get you 0, pi over 4 and 0, order pair. Last, 3 cotangent 2, 3 pi over 8, 3 cotangent 3 pi over 4, negative, okay, so that'll get you a -3, ordered pair, 3 pi over 8 and negative. We came up with the points, our 1/4 of the way, our midpoint, and our 3/4 of the way through. So what I want to do is I graph our asymptotes. Keep in mind that we had an asymptote at 0, and we had an asymptote at pi over 2. So Here's my asymptote at 0. Here's my asymptote at pi over 2. My 1/4 of the way through is at pi over 8, height of 3. My midpoint is at pi over 4 and 0, and my 3/4 of the way through is at 3 pi over 8 and negative 3. So keep in mind that this function looks exactly like the tangent function, except it is flip-flopped. Okay? Very good.